Hello, Java programmers. Let's talk about drawing pictures. Well, we're not going to get that complicated. We'll just draw some shapes. Java has an event-driven architecture that allows us to write our code and put it in the correct location and have it executed at the appropriate time to draw images and shapes and colors and circles and rectangles and arrows on our graphical user interface. The trick is to know where to put the code and to trust Java to execute that code at the correct time. And I have provided for you a working program that we'll use as our basis for discussion. I'll show you where to put your code such that it is executed at the appropriate time. And I'll remind you that it's difficult, or it can be difficult, to get graphics going the right way. And one of the problems is often a flicker issue because we're not quite sure, we're not quite confident that we're doing things the right way, and we start trying to put our code in the wrong place or forcing our code to refresh when it doesn't necessarily need to. So I emphasize again, follow along with me, and you have a working example that we'll talk about. I suggest that you make modifications to that working example rather than starting an entirely new program when you go to write your own code. And then when you feel more confident, if you feel like starting from scratch is something you want to do, then you'll be better equipped to do that. But it's perfectly fine to take what I've given you and use that as a basis to start your work. Now, if you've downloaded the project I provided, then you have a zip file, graphics-drawingstuff.zip, and I'm going to walk you through importing that into your Eclipse environment. I have Eclipse running already. The first thing you need to remember is that you must unzip this file. You can't import directly from the zip file. It might seem like that works, but eventually it's going to get you in trouble. Don't even try it. The first thing I'll do then is unzip, and I'll just put that directly back into my downloads folder. You can put it anywhere you like. If your browser is configured to delete what's in the download folder, this is probably not where you want to put that. But a lot of people work from the downloads folder. I've learned that over time, that people consider that a place to store files. And that's okay as long as you understand the ramifications of that. All right, I've unzipped it. I need that path because I'm going to go back here later and import this into Eclipse. So having it in the downloads folder is somewhat of an advantage because it's a pretty easy place to go look for this file. Actually, this entire folder. I'm going to leave this folder open. I don't necessarily need to. Back to Eclipse. I've started Eclipse. I've selected my workspace. You can see that the workspace consists at this time of all the things we've done together to this point. And I know that I want to tell Eclipse about this new project I've downloaded, and I want that project to be available to me in this workspace. And the way I do that is by executing an import operation. And I can click on File and select Import. And if your screen doesn't look like mine, you might see something like this, where you have a whole boatload of choices. But what we want is under General, and it is called Existing Projects into Workspace. I sent you an entire project, and this is what I do when I grade your work as well. So you're kind of seeing what I go through each time that I grade all of your homework submissions. Select General, select Existing Projects into Workspace, click Next, and then you have to navigate through your file system to where that unzipped folder is. I click Browse, and then I go to Downloads. And as I said, that's pretty easy. If you put it somewhere else, that's fine, as long as you know where it is and you can navigate to it. You have no worries. And then I can select the folder that you unzipped, graphics-drawing stuff. The project is in there. Select Folder. That closes the Select Folder dialog, takes you back to the Import Projects dialog. Eclipse went ahead and examined that folder. They refer to it as the root directory. And every project they found underneath that folder is now displayed to you in that project's list box. That's why it would be a very bad idea to select C:\/ as your root directory in this Import Projects dialog. That would cause Eclipse to traverse your entire C drive and find every project, offering you the opportunity to import all of them into your workspace. Don't want to do that. So I did it very judiciously, and all it found was the project that you unzipped, that I unzipped. The options at the bottom, I don't change any of those. Copy project into workspace should be checked. That's a big deal. It's checked for me by default. If it's not checked for you, make sure that you check it. And then click Finish. If you look at the Project Explorer now, you will see that you have a new project called Graphics-Drawing Stuff. It has a red X on it. I didn't expect that, but we'll see in a moment what that problem might be. If you look at the properties of that project now, you'll see that because you checked the box that said copy the project into the workspace, that project is now physically located in your workspace. It's no longer in the Downloads folder. To be precise, it's in the Downloads folder, but it's also copied into your workspace. Technically, you have two copies of it now. And the Downloads copy I don't care about anymore, but the one that's in my workspace will persist. I can refer back to it later, and I can mess with it right now. All right, let's look at the code. I'm looking to see why I have this red X. I did not expect that, but I don't see any red X's or error annotations on any of the source files in that project. I'm going to try to run this right now because I'd like to see if any errors are manifested. I will click the Run button. Actually, let's open up the main and then click the Run button. Oh, I see a whole bunch of errors. And this is interesting. So I have weird, bizarre, freaky errors. The first of which, there's an error right up on the package statement. And I'm trying to say that this Java file, main.java, is a member of the package called main, lowercase m, main, And Eclipse is immediately unhappy. It says the type java.lang.object cannot be resolved. It is indirectly referenced from, which is a little bit cryptic, and it's indicative of a problem that we should be able to fix. So if you get this issue, this is actually a convenient time for us to talk about it. Let's bring up the properties of this project again. We're going to change a couple of the properties and hopefully make these errors go away. Else I'm going to have to pause this video. So we're going to go to Compiler and configure workspace settings, and we'll let us do that. But what it is saying is that this project has its own specific compiler settings. And what's going on behind the scenes that's causing these errors is that the compiler that this project wants to use is not compatible with what's installed on this computer. So I'm going to unselect Enable Project Specific Settings and then click Apply and Close. Let's see if that makes the error go away. Again, I went to the properties of the project. I selected Java Compiler. I unselected Project Specific Settings, meaning that this project should now try to conform to the workspace settings for the Java compiler. Apply and Close. And even though I clicked Apply and Close, it says, do you really want to do this? Yes, I do. Does that make the error go away? No, it doesn't. But that's okay. We have other things we can try. Go back to the properties again. And let's go to Java build path. And you can see there's an error associated with the JRE, the Java runtime environment. And I'm going to remove that. And then I'm going to add it back. So click on Class Path and click Add Library. And then select JRE System Library. In the dialog that pops up, click Next. Take the workspace default. Again, we're saying that as delivered to you in that project that I gave you, it wants to use a compiler that is not installed on this machine, meaning that it's old, outdated, or even possibly too new. It could go either way. And I'm saying don't look at the project specific settings for the JRE, rather use the ones that the workspace uses by default when you create a new project. Click Finish, Apply and Close again, cross your fingers, and the errors go away. If you didn't get any errors when you imported my project, you don't have to do any of these things. But if you did, going through those two sets of steps should fix those errors. You can see all the red, nasty red lines are gone. Now we can run it, hopefully. And it's not that exciting, but it does work. It draws a beautiful blue rectangle. It draws a little line diagonally. It tries to write some text. Nothing to write home about, but it is an introduction to how to get going with graphics. We can close that again. Now we're back to the project. Okay, before we jump into the slides, just want to point out a couple things to you. Look at the myFrame class in the project and notice that I'm creating a class called it's myJFrame, not myFrame. I'm creating a class called myJFrame, and it inherits from the Swing JFrame class. A common thing to do then is to take an existing class, whether part of Java or provided by a third party, and extend from that or inherit from that, and then add capabilities to it. We're also doing the same thing in myJpanel. we're creating a new class that inherits from the Swing Jpanel class. All right, so there's a little bit of background what we're up to. Let's hit back into the slides again. We talked about event handlers. I'm on slide 5 now. There is an event that takes place that Java says it's time to start updating the graphics. It's time to start drawing lines and circles and painting buttons and labels. And that has to come at a certain point in the life cycle of your program. Now, it's not up to you to decide when that point is. It's not up to you to say, okay, it's now time to paint my screen. That's Java's decision. It's your responsibility to be aware that whenever that time comes, whenever Java decides to update your graphics, it's going to run whatever code you have put into a method called paint component. That's the trick. All the code you put into paint component will be run at the appropriate time on the appropriate event by Java. When you run code in the paint component method, you use what's called a graphics context, or just a graphics object in Swing, and you draw things using that graphics context, and we'll talk more about that in a bit. Let's look at the little pieces of what's going on in that code. If you have a button or a panel or a label or a text area, drop down, checkbox, all of those have a graphics context. And the graphics context is like your little chalkboard or your palette that you're drawing onto. So as long as you know that, you can override that method in your inherited class, and you can add code to that method. And that's paint component. So far so good. We know there's a method called paint component. We know that it always accepts one argument. Hopefully at this point you're looking at this and asking yourself, where does that graphics context come from and what the heck is it? Well, the answer to both those questions is we really don't care. All we know is that if we write this method called paint component and we configure it to accept one parameter, which is a graphics context, then Java will call this method for us, and then we're off to the races. We don't care how it calls it, when it calls it. We don't care how the graphics context gets created. We just depend on the availability of this graphics context being sent to us. A lot of things going on behind the scenes now. The first thing we do in this paint component method is called the superclass method of the same name, and just pass that graphics context up the line. If you think about this in terms of a panel, then there are things going on in that panel that you don't know about. It has a border, it has a background color, it has a size. All of those things need to be painted. Now, they're not our responsibility because they're in the base class. So all we need to do is call the paint component method for that base class, and it will take care of all that. Notice it uses the same graphics context that we do. After we've called the base class base class paint component, it's not a constructor, then we can do whatever we want to do. In this case, I've decided I'm going to draw a line, draw an oval, set the color of the pen, and then draw a rectangle. Where did all these methods come from? Well, I'll show you that in a minute. Again, your takeaway here is that we put our drawing logic into the paint component method. Java calls that method at the appropriate time, and our stuff gets drawn. What do we want to draw on? Well, a very convenient control to draw on is a Jpanel. Remember also we could put other things into a Jpanel like buttons and checkboxes and text areas. We can also draw on that same Jpanel. And if you look at the object hierarchy on the slide, you can see that my Jpanel, the class I created, inherits from Jpanel. And that means I'm going to get all of the benefits and responsibilities of a Jpanel. One of those would be a paint component method and a graphics object. I could draw on other things, but a panel is a convenient thing to draw on. Here's the logic I showed you a moment ago. We're creating a class called it's actually my Jpanel that inherits from Jpanel. And once we do that, we know that we have to put our code in a certain place and it will be executed for us. Event-driven programming again. There's a cookbook framework for you to follow. Just call the superclass paint component method, and then following that put in any drawing logic that you want to include. What you're going to want to do here is you're going to want to put things that use the graphics context, that G. So not a lot of computations if possible, not anything that takes an excessive amount of time if possible, only things that directly impact graphics, bit manipulation, pixels, all that cool stuff on the graphics context object. So your whole program doesn't go in there. Do everything you can outside of this method and only do your drawing inside of this method. For us, that's not a problem because our little simple programs aren't doing a lot of computations. We don't have to worry about it. Here's my J-frame. Now my J-frame, remember, inherits from the swing J-frame. That means I'm going to get a border and a minimize button, a maximize button, a sizable frame, a sizable border. I'm going to get all those things because I inherited from J-frame. But in the constructor of my J-frame, I'm immediately going to drop in an instance of my panel. So I'm doing a lot of the housekeeping work in the constructor of that my J-frame class. All of this is in the program that I gave you that we just ran a moment ago. If you go back and run it again, there's the frame. You can see that it resizes and it moves and it drags and it minimizes and maximizes. All of those capabilities come from the fact that I inherited from Jpanel. So I got all of those neat and awesome features, and they're all part of this thing called my Jpanel now, and I didn't have to do anything except inherit. As a matter of fact, the only thing I care about doing, and I'm back in my Jpanel again, notice, the only thing I care about doing is cramming some code into that paint component method. So far so good. I'm going to go back to Eclipse and I'm going to close the app. I don't need it running anymore. When I leave stuff running, I just get confused and forget it's there. If I want to draw, and let's get down to the nitty-gritty here. 0, 0 is the upper left-hand corner of the panel. In this case, the panel's taking up most of the frame. So when I say 0, 0, whatever I'm drawing on is the upper left-hand corner of that thing. Now let's go find a draw line. in my code. There's one right there. How about that? I am in the Jpanel class, and I am overriding or replacing the paint component method that was provided for me in Jpanel. Therefore, I can say that the My Jpanel class has its own version of paint component, and it contains a request to draw a line, a rectangle, set the color of the pen, and then draw another rectangle. So far, so good, right? What if I want to draw another line? Well, I can just start with this as my little template, and I can kind of work backwards and say, okay, if 0, 0 is the starting point of that line, and that's the upper left-hand corner of whatever container I'm in, then 50, 50 must be the X and Y coordinates of the other end of that line. That means that draw line takes two coordinates, X and Y for the starting point of the line and X and Y for the ending point of the line. And I'm just deriving that by looking at the way the code is written and figuring out what the result is. You can certainly look that up online and get a lot more information about drawline, but just studying it a little bit, you can get a lot of information about how it works. Let's go back to our code again, and let's say, okay, remember, I'm in the paint component method of the Jpanel class, and in that paint component method, I'm asking it to draw a line, from 0, 0 to 50, 50. Let's get a little crazy. Let's say let's draw the line from 0, 0 to 500, 500. I don't even know how big that panel is, but can I go from 0, 0 to 500, 500? And again, I'm encouraging you, I'm trying to inspire you just to experiment a little bit. Just try things and see what happens. How big is this panel? Well, there's no way to tell from here. This is just the class definition. I don't know what the objects look like. So go back to the My JFrame class, and you can see that there's where I create the panel. In the constructor of the My JFrame class, I declare and instantiate something called content pane, and that is of type My Jpanel. And then I give it a border so you can see it. And then I tell Swing that the thing I want to draw on in this JFrame is this panel that I just created. Okay? So I'm saying here, tell Swing that we will be drawing on the My Jpanel we just instantiated. All right? Do you have to change any of this stuff? No. No. You might want to make the sizes a little bigger. You might want to move things around, but as far as do you need to add more content panes and layout managers and things like that? No, you don't have to. If we look up above, we can see that our frame is not that big, right? Well below 500 by 500. What's going to happen then when I try to draw from 0, 0 to 500, 500? There just isn't enough room. That line is going to run off the edge of the frame. Well, my curiosity is, will it crash the program? Will it give me an error? Will it print some warning? Will it refuse to draw the line at all because it all doesn't fit on the frame? Well, let's find out. There it is. As you can see, it just runs off the end of the frame. So what we call it got clipped, and it doesn't interfere with any of the other windows on the screen. My desktop looks fine. It only drew what it was able to draw, and it couldn't draw anymore. So it just kind of lost it. Well, that was interesting. What if I put some ridiculous number in here? Minus 500. I'm asking it to go from 0, 0. Let's take this comment out. This is confusing. I'm asking it to go from 0, 0 to minus 500, minus 500. And that's going to be from the upper left-hand corner backwards, if you will, to farther off the screen, because we're already as far as we can go up to the corner of the panel. There's nowhere else to go. What will that do? That didn't do anything. You can see the little tiny line there that was from 0, 0 to 50, 50, but 0, 0 to minus 500 is just impossible. It can't be done, and it just didn't do it. So one of the things you have to deal with sometimes is the lack of diagnostics, the lack of error messages and warnings, and the understanding is that you asked it to do something impossible, and it just said, hey, I can't do it. So I didn't get that second draw line to do anything. It could get frustrating. You think it's right, the syntax is correct, there are no red lines underneath any of your code, but the logic is wrong. You asked it to do something that was just impossible, so it didn't do it. Can't do this, doesn't make any sense. Okay. Well, how did we get this far? In the main method, all I had to do was declare and instantiate one of my JFrame objects and then make it visible. That's all I had to do. When did it start drawing? Well, somewhere it started drawing. Somewhere in these two lines of code, an event happened, and that event caused Java to call the paint component method that I worked so hard to create, and then it painted on my panel. I don't know when that is. I don't know if it happened when I made it visible. I don't know if it happened when I instantiated the JFrame. I don't know. All I know is that somewhere in that two lines of code, it called my paint component method. And that's your biggest takeaway from this presentation, is that if you put your code in the right place, eventually Java will call it for you and it will get executed. The good news is that it's kind of hard to put it in the wrong place. And I mean, certainly we can make mistakes, and we will, but if I try to do a draw line, I need a graphics object, and the only time I'm going to get a graphics object is when paint component is invoked. Remember, that graphics object comes from somewhere well beyond my control. It's provided to me, and then I get to use it. So if I go back to the main again, and I say something like graphics G equals new graphics, because I know I need a graphics object, so I'm going to make one. I'm unclear where it comes from. I don't know that I need a panel. I just know I need a graphics object. And what happens, it says that, I don't know what that is, but it's offering to tell me where to find what that is. Okay, I'll take that fix. The errors go away. One of them does anyway, because it knows now what a graphics object is. Notice right here, everything that I've been telling you. The abstract base class for all graphics contexts that allow an application to draw onto components. Allow an application to draw onto components. That's what we've been doing. Without a graphics object, you can't do it. The other error that I get is, since it's abstract, it cannot be instantiated. So I can't create my own graphics context object. I just can't do it, which is kind of good news. That's another mental reminder that you have to have a paint component method to let Java provide you with that graphics component, that graphics context object. So put your code in there and everything works, he said confidently. Now, I've been holding off on this to this point, but if you go to the Java documentation, you can find all of the interesting things that a graphics object will do for you. All the things it will draw. It'll draw ovals and circles and lines. It'll fill rectangles and do all of these neat things. And of course, you could do even more searching online and find wonderful examples of people using these methods to draw very complex shapes. We're not interested in mathematical complexity at this point. We're just interested in understanding the process that we go through to draw things. Therefore, if we can draw a box and a line, I'm happy. I don't care that it doesn't look like much. I just care that we got it to work. So don't stress out over drawing a wonderful three-dimensional rotating sunflower that plays the Star-Spangled Banner. That's okay. We don't have to do that. All right. Here's some more paint component logic. You should be able to look at that and have some idea what in the world's going on. Again, if you don't know, refer back to the documentation. There's a function called draw rect. It requires a graphics object, which we have been referring to as G. We can call anything we want, but G makes sense. And as you can imagine, this draw rect is going to create a two-dimensional rectangle. The upper left-hand corner will be at 0.00. The lower right-hand corner will be at 0.200, 300. So these things are pretty easy to figure out. If you want to set the color of the pen, you can call set color. And the argument passed to set color is a color object. In this case, we're passing it the color object blue. And then everything you do from then on will be in that color. So when we fill this rectangle, we're going to get a blue rectangle. So let's just grab this code right off the slide. And let's go back to our paint component method and just blow everything away. Just take it all out of there. The only thing we need to preserve is that call to the base class constructor, or base, I keep saying constructor, base class paint component. So this line should persist. So this line lets the base class do its own drawing operations. There may not be any. The base class object may not need to do any drawing, but at least give it a chance to do so. And once that guy is finished, we can have our way with the graphics object G. So we're drawing a rectangle, then we're setting the color to blue, and then we're doing a filled rectangle. Let's see what we get. Notice nothing else has changed. I didn't change the main, The main still has 2 measly lines of code in it. I'm focusing solely on what's going on in this paint component method. Let's see what I get. There it is right there. Now where did this text come from? Which is very hard to read. It says my gr ... I don't see that in here. Well, it had to come from somewhere. Let's look around. In the constructor of the myJFrame class, I'm putting in a label object and I'm initializing the contents of that label object to my graphics. But I'm making a crucial mistake in that the size of that label object does not have enough capacity to contain my space graphics. It's not long enough. That's why all you can see is part of that text. And that's an illustration then that I can put controls on the same container that I'm using to draw my circles and arrows and all the other neat things. I hope that was helpful. Remember, you don't have any control over when your screen is updated. In these very simple examples, this is not a problem. In more complex examples where you're updating things in real time, then you might say, hey, why did I try to draw a circle and I still don't see the circle 2 seconds later? And the answer is Java just has not gotten around to drawing that circle. We don't have any control over that, and that takes a lot more study to understand what we might do to get around those kind of problems. I'm happy if you can run this program as I gave it to you and make modifications to the code in the paint component method to draw things. If you can do that, you're in good shape. We're not concerned about the complexities of getting things to update in real time. So with that, I will bid you adieu, and I encourage you to get in there and start drawing and getting a feel for how easy this is. Thank you.